All right, the second way, or a second way that you can have a limit not exist is something called unbounded behavior. So unbounded behavior, for this we're going to use the example f of x equals 1 over x squared. Let's look at the graph of this. This is one of the functions in our catalog of essential functions. I'll use my red marker here. There's one side. There's the other side. X squared, right, is going to be positive on both sides. So there's the graph of that function. And it's useful to note that as x approaches 0, the denominator of this function, which is x squared, that's also going to be approaching 0. But in particular, no matter whether x is approaching 0 from the left or the right, like no matter what x is like just less than 0 or just more than 0, right? X squared is going to be getting closer and closer to 0, but specifically from the right, meaning positive numbers. As x squared is approaching 0 from the right, it means we're getting closer and closer to 0, except specifically with positive numbers. And then 1 over x squared is like taking 1 divided by very, very, very small positive numbers. Have you ever done this on your calculator? You do 1 divided by 0.1, and 1 divided by 0.001, and 1 divided by 0.000001, and then you see what you get, and you keep getting larger and larger and larger and larger numbers. So this overall expression here is going to be approaching positive infinity. And this information is reflected in the graph. As x is getting close to 0 from either the left or the right side, we see the points on the graph are rising up, 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 and shooting up towards positive infinity. That's from the right, and then from the left we see up, 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 shooting up towards positive infinity. So in this situation, this is called unbounded behavior. There's no number which the function values are approaching as x gets close to 0. So we say that the limit as x goes to 0 of 1 over x squared does not exist. For now, because in like a little bit later, maybe next week, or possibly the week after, I can't remember when it's scheduled, but we're eventually going to talk about infinite limits, and we'll decide just sort of almost arbitrarily, like, well, you know, in this situation we can say that we could say, and it's useful to say that it's approaching positive infinity. But technically, this is just an example of a situation where the limit does not exist. So for now, the correct answer is this one. Does not exist. All right.